Welcome to the second chapter of Class 10th Science book. In this chapter, we will discuss about acids, bases, and salt and their reactions. Acids and bases are like the superheroes of the chemical world, doing important jobs that affect everything around us. Let's break it down in simpler terms. Acids have a unique taste, kind of sour. They can make blue paper turn red, showing they are acidic. Picture them as the tough guys who can even corrode metals, making them go all rusty. Now bases are like the opposite. They taste a bit bitter and turn red paper into blue, providing they are alkaline. These are the calm and soothing characters that neutralize the tough acids, helping to keep things balanced. But it's not just a lab thing. Acids and bases are all around us. Think about the tangy taste in citrus fruits or the soapy touch in cleaning products. That's the result of these substances mixing and mingling. Now imagine them in a chemical dance when acids and bases meet. They create something new called neutralization. A bit like a perfect fusion, this magic reactions not only balances things out but also opens door to lots of cool stuff like making yummy food or important medicines. So, in our world of chemical reactions, acids and bases are the stars of the show. They bring a balance, create new things, and leave their mark on everything from what we eat to how we clean. It's like a superhero duo making our everyday world a bit more interesting and well balanced. In the vast realm of science, these exists a microscopic world of incredible importance, the world of acids. Now we embark on a journey through this fascinating landscape, exploring the properties and examples of these unsung heroes that impact our lives in more ways than we realize. Picture a lemon, bright and yellow, ready to impart its zesty flavor to a refreshing glass of lemonade. The magic behind that tangy burst is citric acid, a compound found abundantly in citrus fruits. It's not just about taste. Citric acid is a culinary maestro, enhancing flavors and making our favorite dishes and drinks come alive. Now let's shift our gaze to the kitchen cabinet, where a humble bottle of vinegar sits. Behind its unassuming appearance lies acetic acid, a key player in the world of preservation and condiments. Pickles owe their tanginess and extended shelf life to this acid, showcasing how acids quietly contribute to our culinary experiences. Imagine a quiet hero within us, hydrochloric acid in our stomachs. It may not boost a delicious taste, but its role in digestion is crucial. Breaking down food into digestible components, hydrochloric acid ensures that our bodies can absorb essential nutrients, keeping us nourished and energized. Moving to a festive scene where soda bubbles with effervescence, delivering a delightful experience to our taste buds. Carbonic acid, formed when carbon dioxide dissolves in water, is the invisible force behind this Fiji celebration in every shape. Transition to a industrial landscape where sulfuric acid takes center stage. It plays a pivotal role in processing ranging from manufacturing fertilizers to refining oil. In this realm, acids becomes workhorses, shaping products that fuel our modern lifestyle. Yet the influence of acids extends far beyond these examples. They are silent factors in cleaning products, pharmaceuticals, and even the intricate processes within our bodies. DNA replication, a fundamental biological process, involves acids in a complex dance of molecular precision. As we navigate the intricacies of acids, it becomes evident that these molecules are not more chemical entities confined to laboratories. These are integral to the stories of daily lives, contributing flavor, preserving foods, aiding digestion, and playing essential roles in industries that shape our world. In conclusion, this exploration into acids serves as a reminder of the subtle yet profound impact these molecules have on our existence. From the kitchen to laboratory, from our bodies to industrial processes, acids are the invisible architects, adding both zest and substance to the intricate tapestry of our lives. Here is the unsung heroes, acids quietly enriching our experiences in ways we might not always notice. Now, welcome to the intriguing world of bases, often overlooked yet crucial players in the dance of chemistry. In this journey, we will unravel the unique properties of bases, explore their diverse personalities, and discover how they subtly shape our daily lives. At the core of our chemical tale are bases, counterparts to acids. Picture a magical substance that, when mixed with water, releases hydroxide ions, the undercover agents of the base world. These ions set the stage for a range of reactions influencing everything from cleaning products to the human body. If acids are the superheroes with low pH values, bases step in as the counterbalance with higher pH values. The pH scale designates 7 as neutral, with values below indicating acidity and those above indicating alkalinity. Bases, with their higher pH values, bring a sense of balance to this chemical tango. Have you ever pondered why soap feels slippery? Enter the magic of bases. Their unique ability to react with fats, and oils leads to the creation of soap, a chemical superhero in the world of cleaning. So, the next time you are washing your hands or enjoying a bubble bath, you can thank bases for their soapy wonders. Just like acids, bases come in various types, such as each with its own personality. Some bases are robust and efficient, swiftly getting the job done, while others take a milder approach. Ammonia, a common household base, not only features in cleaning products but also plays a role in our own bodily processes, showcasing the versatility of bases. One of the most intriguing aspects of bases is their ability to neutralize acids. Picture a chemical dance where opposites not only attack but create something entirely new. When bases and acids meet, they engage in a molecular waltz, producing water and a special compound known as salt. It's the chemistry equivalent of harmonious duet. Bases are not elusive entities confined to laboratories. You encounter them more often than you might think. Sodium hydroxide, a powerhouse in cleaning products, take on stubborn stains with vigor. Baking soda creates fish when it meets vinegar, a lively reaction resulting from a base and acid engaging a spirited conversation. Just, just as with acids, bases deserve a degree of respect. Concentrated bases can wield significant strength, so it's crucial to handle them with care. In the chemistry of our daily lives, responsible handling ensures our bases remain helpful sidekicks rather than unpredictable forces. Beyond households applications, bases play integral roles within our own bodies. The body's internal environment relies on a delicate balance of acids and bases. For instance, the bicarbonate ion helps regulate the pH of our blood, showcasing how bases are silent guardians of our biological equilibrium. Understanding these extends to their impact on the environment while they play essential roles in various processes. Their disposal requires mindfulness. Responsible practices ensures that bases don't leave a harmful footprint, contributing to the broader conversation of sustainable chemistry. As we conclude our exploration into the world of bases, let's raise a metaphorical glass to these unsung architects of chemistry. From the soap opera in our bathrooms to the silent guardians within our body, bases quietly shape the chemistry of our lives. Their diverse personalities, from robust cleaners to biological regulators, make them indispensable players in the intricate dance of molecules. So there is two bases, the silent influencers that bring balance to the chemical symphony of our everyday existence. Beyond the world of acid and bases, salt, a fundamental class of compounds resulting from the neutralization of acids and bases, exhibits a remarkable array of properties that contribute to its diverse applications in numerous fields. The chemical structure of salt is characterized by the combination of positively charged ion and negatively charged ion, resulting in a balanced electric charge. This intricate balance between charged species gives rise to several notable properties of salts. One prominent property of salts is their ionic nature, stemming from the electrostatic attraction between oppositively charged ions. These characteristics often leads to the high solubility of salts in water, as the polar nature of water molecules can effectively surround and separate the ions, facilitating dissolution. Sodium chloride or table salt exemplifies this property as it readily dissolves in water, forming a clear solution. Similarly, potassium nitrate, commonly used in fertilizers, is another example of salt with high solubility. This property is crucial in various applications from chemical reactions in laboratories and formulation of pharmaceuticals, where solubilities play a pivotal role in drug delivery. The dissociation of salts into ions when dissolved in water imparts electrical conductivity to their solutions. This property is exploited in various fields, including chemistry and biology. For instance, sodium chloride solutions conduct electricity due to the presence of sodium ions and chloride ions. This electrical conductivity is harnessed in applications such as electrolysis, where the decomposition of water into hydrogen and oxygen occurs. In a similar vein, potassium chloride is often used as an electrolyte in batteries. The movement of ions between the cathode and anode during the electrochemical reaction contributes to the flow of electrical current. The conductive nature of salts underlies their significance in energy storage and electrochemical process, and the melting and boiling points of salts are generally higher than those of molecular compounds. This is attributed to the strong electrostatic forces holding the ions together in a three-dimensional lattice structure. For instance, sodium chloride has a high melting point of 801 degrees Celsius, making it suitable for various high temperature applications. including metallurgical processes. Similarly, calcium chloride, widely used as a de-icing agent, has a relatively high melting point, allowing it to effectively melt ice on roads and sidewalks during cold weather. The ability of salts to withstand high temperatures makes them valuable in industrial processes and applications where heat resistance is crucial. Many salts exhibit hygroscopicity, the ability to absorb water vapor from surrounding environment. This property is exemplified by substances like calcium chloride, which readily absorb moisture, leading to the formation of a damp or liquid solution. Calcium chloride's hygroscopic nature is exploited in applications such as dehumidifiers, where it effectively removes excess moisture from the air. Additionally, magnesium sulfate, commonly known as Epsom salt, is hygroscopic and often used in bath salts. Its ability to absorb water enhances its dissolving properties in bath water, contributing to the soothing and relaxing effects claimed by proponents of Epsom salt baths. Certain metal ions present in salt exhibit distinctive colors when exposed to a flame. This phenomenon, known as the flame test, is utilized in qualitative analysis to identify the presence of specific metal ions. For instance, sodium imparts a yellow color while potassium produces a violet hue. These flame test colors aid chemists in identifying elements in compounds, showcasing the diagnostic utility of salts in analytical chemistry. Copper sulfate, when subjected to flame test, produces a characteristic green color due to the presence of copper ions. This property is employed not only in analytical chemistry but also in educational settings to visually demonstrate the connection between the composition of a substance and its observable properties. Salts play a crucial role in regulating pH levels. The neutralization reaction between an acid and base that forms a salt inherently involves adjusting the acidity or alkalinity of a solution. Ammonium chloride, for instance, is an example of salt that can undergo hydrolysis in water, influencing the pH of the solution. This property is harnessed in various chemical processes and serves as a foundation of understanding acid-base equilibria. Another example is sodium bicarbonate, commonly known as baking soda. While not a traditional salt, its alkaline nature contributes to its ability to neutralize acids, making it a versatile compound in culinary household application. In conclusion, the properties of salt, ranging from their iconic nature and solubility to their conductivity and flame test, make them indispensable in diverse applications. These compounds, born from the interaction of acids and bases, showcase a dynamic interplay of chemical and physical characteristics. From everyday uses like seasoning food to critical roles in industrial processes, the properties of salts underscore their significance in shaping our technological, scientific, and culinary landscapes. The intricate dance of ions within these compounds continues to inspire innovation and discovery across various fields. Now we will explore the differences between these fascinating characters, keeping things simple and relatable. Acids are like the rock star of the chemical world, bringing a zing to everything they touch. When mixed with water, they release hydrogen ions, creating that unmistakable tanginess in lemons or the kick in your favorite soda. Now meet the humble bases, the quiet heroes that balance the chemical stage. When bases mix with water, they release hydroxide ions, working behind the scenes to create a slippery sensation in soap and quietly break down grease and grime in cleaning products. To understand the differences, we will introduce the pH scale, or ultimate scoreboard for acidity or alkalinity. Acids, the rock stars, score below 7, while bases, the unsung heroes, score above 7. Imagine biting into a lemon or tasting your favorite soda. That burst of tanginess is the work of acids. They are like the flavor enhancers in our food and drinks, giving them that extra kick. Acids also have a knack of fizziness. Drop a piece of metal into cola, and you have got a tiny science experiment with acids at the helm. Shift the spotlight to bases. Ever wondered why soap feels slippery? Bases, with their unique ability to react with fats and oils, create the magic behind that slippery sensation. They are the unsung heroes in our cleaning products, quietly breaking down grease and grime. One of the coolest moments in chemistry dance is when acids and bases come together. This magical moment, known as neutralization, results in water and a special compound called salt, the harmonious duo of the chemical world. Think of acids as the celebrities in your kitchen. Lemon juice, vinegar, and even the fizz in soda are all brought to you by acids. On the other hand, bases are the behind the scenes worker. Baking soda, ammonia in cleaning products, or the soap in your bathroom. Both acids and bases have their superpowers, but they need to be handled with care. Concentrated acids can be strong like superhero with too much power. Responsible handling ensures they remain helpful allies rather than unpredictable forces. Beyond the kitchen and cleaning cupboard, bases play vital roles within our own bodies. The balance between acids and bases is crucial for our internal environment. Bicarbonate ions, for instance, help regulate the pH of our blood, showcasing the silent influence of bases in our biological harmony. Understanding the differences between acids and bases also extends to the impact on the environment. Responsible practices in their disposal ensure that their influence doesn't leave a harmful footprint, contributing to the broader conversation of sustainable chemistry. As we wrap up our exploration of acids and bases, let's raise a virtual toast to the chemical symphony they create in our lives. From the tangy wonders of acids to the subtle influence of bases, these characters play integral role to the everyday dance of chemistry. So, here is to acids and bases, the dynamic duo shaping the flavors, sensations, and clean spaces in our world. Now we will discuss about neutralization reaction in between acids and bases. In this exploration, we will unveil the magic that happens when acids, bases, and salts come together. In the chemical dance, acids play the role of giving away protons, while bases are the happy receivers. This dance creates a delicate balance between two, resulting in a peaceful and balanced state. Imagine a stage where acids and bases meet. The acid gives its proton to the base, leading to the creation of water and a salt. This marks the end of their dance, leaving everything calm and balanced. Balanced equations in chemistry serves as the language to describe this dance. They show the exact amount of each part, making it like a perfect choreography where everyone knows their steps. After this chemical dance, something special is left behind: salts. Salts some come in many types, like the table salt we use in cooking. They are like the souvenirs from the dance, each with its own story. Outside the lab, neutralization reactions have real impact on our lives. Think about antacids, those tablets that help with too much acidic stomach. They use the power of bases to bring balance. Also, wastewater treatment plants use neutralizers to protect the environment. Now let's talk about a fancy move called titration. It's like a super accurate dance move where chemists can figure out exactly how much of each thing is involved. This helps them understand known solutions better. Zooming into the tiny world of molecules, we see them doing a special dance during neutralization. Protons exchange in a specific way following the rules of chemistry. This dance might seem simple, but it's super reliable and predictable. Neutralization doesn't just happen in labs, it's also in nature. When rainwater, a bit acidic, meets or soil minerals, it's like a natural dance that balances things out. This shows how neutralization is part of keeping nature in harmony. Neutralization is like a meeting point for different ideas in chemistry. Some say acids and bases make ions, others talk about proton transfers. Exploring these ideas helps us see the bigger picture of how chemistry think about neutralization. In this simple exploration of neutralization, we have seen how it's like that a thread weaving through the fabric of chemistry, from tiny dances of particles to everyday applications. Neutralization reveals the magic and precision in the world of atoms and molecules. It's like a beautiful dance that shapes of chemistry of our world. Now the last part of this video, let's explore the practical applications of acids, bases, and salts in our daily lives. Acids are prevalent in the foods we consume, providing a tangy flavor to citrus fruits and vinegar. In the stomach, gastric acids aid in digestion. Beyond our diets, acids are crucial in cleaning. For instance, citric acid in bathroom cleaners dissolve mineral deposits, while sulfuric acid is fundamental in industrial processes like fertilizer production and synthesizing various materials. Batteries, powering, or electronic devices often rely on acid-based electrolytes for their functionality. Bases with their alkaline properties are vital in maintaining cleanliness and personal hygiene. Soaps and detergents use bases to emulsify oils and remove stains. Toothpaste, incorporating basic substances, contributes to oral health. Ammonia, an alkaline compound, is a key ingredient in cleaning products and fertilizer production. Bases also play a pivotal role in chemical reactions, facilitating the synthesis of pharmaceuticals and polymers. Salts formed through the interaction of acids and bases go beyond seasoning or food. They are crucial for food preservations, acting as natural preservatives in pickling processes. In water treatment, certain salts help purify water, ensuring safe drinking water for communities. Salts also contribute to metallurgy, aiding in the extraction of metals from ores. In health, the delicate balance between acids and bases is paramount. The pH balance in our blood, slightly basic, is tightly regulated for optimal enzyme function and metabolic processes. Disorders affecting this balance can lead to serious health complications. Medication often utilize acid-base principles for controlled drug release and therapeutic effects. Environmental Environmental concerns underscore the importance of acids, bases, and salts. Acid rain resulting from emissions of sulfur dioxide and nitrogen oxides adversely affects ecosystems, emphasizing the impact of human activities on the environment. In conclusion, the practical applications of acids, bases, and salts are diverse and integral to our daily lives. From the flavors in our meals to cleanliness, industrial processes, health, and environmental sustainability, these chemical entities play vital roles in shaping the world around us. In this video, I delved into the fascinating world of acids, bases, and salts, unraveling their essential properties and reactions. Whether you are a curious learner or a student navigating the intricacies of chemistry, this content is tailored for you. Don't miss out on future insights and knowledge. Make sure to hit that subscribe button and join me on this educational journey. Thank you.